Welcome to our Let's Talk Data podcast series. My name is Nathaniel Martinez, and I'm happy to introduce to you our topic for today. If you haven't done so yet, please subscribe or follow our podcast wherever you listen to podcasts. Today, we are joined by VASPP, one of our key partners who participated in the most recent content sprint for SAP Data Intelligence. Our SAP Data Intelligence product team works closely with partners such as VASPP to develop specific use cases and content for SAP Data Intelligence. The content developed enables companies to get started quickly on specific scenarios, ensuring quick time to value. Today's podcast is about commodity price prediction with SAP Data Intelligence. Ratan, Yedla and Sumanth Krishnan from VASPP discuss how commodity price prediction works with SAP Data Intelligence. They discuss the use of AI and machine learning models to predict future prices based on previous patterns, external events, and IoT data, with less forecast error to enable better buying decisions, which help yield cost savings for organizations. VASPP did this work during the SAP Data Intelligence content sprint. We hope you enjoyed today's podcast. Be sure to check out the links in the show notes to learn more.
Hello and welcome to podcast on price prediction. I'm your host Ratan Yedla. Today we will talk about commodity price prediction using SAP Data Intelligence with our guest Sumanth Krishnan, a product developed by VASPP as a part of SAP Hackathon 2021. We will discuss ins and outs of commodity prices prediction. Be sure to listen all the way through the details. Before we get to the solution, I would like to talk about VASPP. VASPP is a multinational global organization working on products and IT services. A prominent player in technology, database, and analytic topics with worldwide customer operations. VASPP has contributed many assets for organizations to solve their business problems using IT and analytics. Hi Sumanth, thank you so much for joining us.
Hi Ratan, thank you for having me today.
To start with Sumanth, can you tell us what commodity price prediction is?
Ratan, it's basically the prediction of prices on commodities determined by, say, supply and demand, as it would vary according to the imbalance at any one period of time.
If you could give us an example, please.
Well, Ratan, a booming economy might lead to increased demand for oil and other energy commodities, and their price could be determined. To start with, the solution is apt for industries like agricultural, chemical, manufacturing, and automotive.
So, is it just the four industries the solution would work on?
It may fit other industries as well, Ratan.
Alright. So, Sumanth, is the solution target specific? If yes, our listeners are keen to know.
Ratan, the main target here is to reduce the cost and increase the margin. Typically, the expenses the companies would spend in terms of, say, buying and importing goods, which is raw materials, that will internally go through the process of manufacturing, refining, and the finished goods will be coming out. So the main expense that they spend is in procuring the raw materials. It could be commodity, oil, ore, or even gas.
So, you are saying that there is a workaround solution for this?
Yes, we have.
Sounds good. Sumanth, could you let us know if we need to consider factors like price fluctuation in the market or any other factors that you could tell us about which could lead to the prediction of future prices?
Our solution on commodity price prediction is targeted to find out the price fluctuation in the market, how it impacts the prices at which they buy, and the whole problem statement around this solution, Ratan, is to go find what is the pricing in the past. They have bought it, and what are the influencing factors which are affecting the prices, and then we use artificial intelligence and machine learning models to predict what could be the future price trends.
So you're saying that the data you would retrieve would come up with the forecast?
Yes, of prices, Ratan, that too with good accuracy, I would say.
Sumant, we also want to know if the solution would help in reducing the cost.
Rather with accurate predictions of prices, we are trying to reduce the cost to enable the procurement teams or some of their decision makers have some informed decisions that they're going to probably have the prices spiked up in 2 to 3 weeks or 2 to 3 months, or it's already at all-time high, or say it's the lowest pricing that they have seen. and it could be possible if they should go ahead and make the buy decision or not.
So this is basically the overview of what the solution does.
Yes.
Okay, Sumanth. And are there any challenges that encountered during this process, or are there any stages or steps involved?
Typically, Ratan, the problems around getting this, and it's not that nobody is doing it. There are manual methods people adopt to do it. So one main factor that they try to understand is the buying pattern, which might be there in their ERP system, or it might be there in different files, or they might be looking at historical prices from different sources, let's say APIs or OTT sources. So they might collect all this information, and that is the first stage where the challenge begins, Ratan, and to collect this data, as all the data will be in different formats and different sources.
And what about the second challenge or step? Could you explain it in brief, please?
Sure, Ratan. The second step is to correlate all the data and try to find out what is going according to the data. Let's say, like, if there are any missing point, or how do we extrapolate, or how do we input some values to get the insights there. Then also to find out if there are some outliers, like if there were some, say, big market fluctuations. That is something which you cannot use to look at a trending or do a forecasting exercise. So how do you correct that data? This is the second challenge for most of these industries, that they try to address it manually. To do it using different tools, people use Excels. Some of them use some kind of coding platforms to do it, and it's not a simple exercise.
I agree. It doesn't sound simple, and it sounds time consuming too.
Yes, it is.
So, Suman, what happens next? I'm just curious. It is a very interesting topic, I must say.
Well, I'm glad, Ratan, that you are. So now the role of a data scientist comes into picture, where they start turning out models and assuming that this whole data curation, data transformation, and data cleaning exercise is done now, according to the steps we've spoken. If that is in place, the data scientist comes and starts creating the models. And since we are talking about the data scientist doing it on his own, he might be able to churn out around, say, 15 models or even 20 models with limited tuning.
I want to know if the data extracted is specific or if it's made available in a particular order or in any other formats.
Yes, I'll tell you how it is. Once the data scientist is done with the job, he might turn out the prediction model and can give some output. And his outputs again are not uniformly available in any tools written. So they might push it into a CSV or an Excel and then they might look again into manual methods to compare the prediction percentage or even the forecast accuracy. Then they end up writing codes again and doing manual work around that. So this whole cycle has multiple challenges.
So basically, there are multiple levels or challenges to each of this. Could you explain how your solution is going to overcome these challenges?
Coming to the solution that we have, it uses SAP Data Intelligence, which is of data warehousing cloud, and then SAP Analytics Cloud. So a combination of these three, we are using them to bridge the gap for the challenges that we spoke of earlier. So starting with data collection, we are using data intelligence to create pipelines, connect to various sources, get all the data into one single place. And at this point in time, we are looking at data warehousing cloud. It's a place where we are storing all the data. So once done, it's an automated process, which can be triggered on a click of a button or can also be scheduled.
What is data intelligence used for now?
Again, Ratan, using data intelligence, we perform EDA, that's early data analysis, creating the outlier corrections, imputations, data cleansing, and then we are using pipelines to create machine learning models. Because we are using data intelligence, we do not have any restrictions. We have kind of churned, say, 50 to 60,000 models
Those many models. With what?
with hypertuning parameters, Ratan, all handled automatically in the system. The system goes, churns out the data and comes out with predictions, looks out for the best model and promotes it to the next level. That way, the entire process is already automated. What we also do is the individual results that are coming in are stored back into the data warehousing cloud. So that is a one-stop go for all kind of analysis and prediction needs and forecast accuracies is also automated as it is going to the same place. So the calculations are in place.
Okay, Sumanth. So once the predictions and the forecasting results have been brought into data warehousing cloud, how does the end user take a look at the end results?
In a way, if you see, Ratan, we are looking at an end-to-end implemented or deployable solution, which is taking the data, doing the curation, and then running the models, giving the output and showing the results in SAP Analytics Cloud at the end. So SAP Analytics Cloud is on top of the result. It is the reporting tool, but it gives you all the slicing and dicing and the trending capabilities to look at the historical prices, look at the forecasted prices now with different tunings, and then they can look at if it is fitting to their error percentages they want to get, because it is always a comparison between the actual and forecast, and it's a continuous learning. This model is deployed in the solution and it will learn on the go and improvises also on its own. And if you want to do a further analysis, further tuning, that is also possible.
So is that the end of the solution or there any more surprises left for audience?
I guess not, Ratan. That should do the job.
Well, Sumanth, and our audience would like to know the key benefits of the solution.
Well, that's a good question you asked, Ratan, here. I would say multiple options. So let's say we have up to 20% decrease in time spent on searching the data. It's 10 times faster reporting cycles using machine learning. We see a strong position in the market. It has automated workflow. The data volume performance increases, and you can own the model, also control changes and costs.
Great to hear. So, folks, our dear guest Sumanth has clearly explained both the problems and the solutions surmounting the predictions on commodity prices, which is a challenge many industries are currently facing, which was pretty easy for us to understand. Sumanth gave us an idea of how the process and the work around happens in the simple words. It was nice having you on the show, Sumanth, and thank you folks for listening.
Thank you, Ratan.
We hope you enjoyed today's podcast. Use the link in the show notes to learn more. If this topic is of interest to you, then you might enjoy episode 29, the integration story and the role of master data. We look forward to seeing you on the next episode of the Let's Talk Data podcast.